Long ago, in ancient Greece, philosophers began to ponder the universe in new ways. They sought to understand the fundamental nature of reality, the basic building blocks of everything around us. These early thinkers, the pioneers of natural philosophy, are now recognized as the first physicists. They didn't have sophisticated instruments or laboratories. Instead, they relied on observation, logic, and imagination to explore the cosmos. These ancient physicists were particularly fascinated by the concept of change. How could the world around us, so full of diversity and transformation, arise from a limited set of fundamental principles? To answer this question, they developed two primary modes of explanation: condensation, rarefaction, and segregation. Imagine a sponge. When you squeeze a sponge, you condense it. When you release it, it expands or rarefies. This process of condensation and rarefaction was one way ancient physicists explained change. Segregation, the other key concept, involved the separation of different substances from a primordial mixture. Think about a jar filled with sand and water. Initially, they appear mixed. However, over time, the heavier sand settles down, separating from the water. This natural process of segregation fascinated ancient physicists. One of the most intriguing aspects of ancient physics is the role of contraries or opposites in the formation of the universe. This idea, central to many ancient philosophies, proposed that everything arises from the interplay of opposing forces: light and dark, hot and cold, wet and dry. These contraries, according to ancient physicists, are not merely different states of being, but active forces shaping the world around us. The ancient Greeks believed that the universe was composed of a few basic elements, but they didn't always agree on what those elements were. Some, like Thales, thought everything was made of water. Others believed in fire, air, or earth as the fundamental substance. Empedocles proposed four elements: earth, air, fire, and water. He believed that these elements combined in various proportions to create everything we see around us. These elements weren't static. They interacted with each other, constantly mixing and separating, driven by two opposing forces: love and strife. Love brought elements together while strife pulled them apart. This constant interplay of forces created the ever-changing world around us. Imagine a cosmic dance with elements swirling and combining, separating and recombining in an endless cycle of creation and destruction. This idea of contraries was not limited to the physical world, it extended to the moral realm as well. Good and evil, justice and injustice were seen as fundamental opposites, shaping human behavior and society. This holistic view of the universe, where physical laws mirrored moral principles, is a hallmark of ancient Greek thought. The idea of contraries wasn't just about opposites, it was about balance. The universe, according to ancient physicists, strived for equilibrium. When one force became too dominant, the other would eventually push back, restoring harmony. This dynamic balance ensured the universe's stability and continuity. The concept of contraries found a prominent place in the philosophy of Plato, one of the most influential thinkers of all time. Plato, while not strictly a physicist himself, deeply influenced the course of ancient natural philosophy. He introduced the concept of the great and small, two fundamental principles that he believed governed the coming to be and passing away of all things. Imagine a block of clay. You can mold it, shape it, make it larger or smaller. But the clay itself remains the same. Plato believed that the physical world was like this clay, constantly changing form, but ultimately composed of the same fundamental principles, the great and the small. These principles, while abstract, had profound implications for understanding the physical world. They provided a framework for explaining how things could change while still maintaining their essential nature. It was like having a set of universal molds that could create an infinite variety of forms. Plato's ideas, particularly his concept of the great and small, had a lasting impact on ancient physics. They provided a theoretical foundation for understanding change and diversity in the natural world. His influence can be seen in the work of later philosophers and physicists who continued to grapple with the relationship between the fundamental principles of the universe and the ever-changing phenomena of the world around us. Section 4. The Infinite and the Finite, a Philosophical Tug-of-War. The question of infinity was another major theme in ancient physics. Some philosophers, like Anaximander, believed that the universe was born from an infinite, boundless substance called the apeiron. This apeiron contained all the potential for everything that ever was, is, and will be. Others, like Anaxagoras, argued for an infinite number of infinitely small particles called seeds. These seeds combined in various ways to create the diversity of the universe. Imagine a giant Lego set with an endless supply of bricks. Each brick represents a different seed, and their infinite combinations create the complex structures of the cosmos. However, the idea of infinity was not without its critics. Empedocles, for example, argued that it was impossible to have an infinite number of elements. If there were, he reasoned, the universe would be completely uniform, with everything mixed together in equal proportions. There would be no differentiation, no distinct objects, just a homogeneous soup of infinite ingredients. To resolve this dilemma, Empedocles proposed that while the elements themselves were finite, the forces acting upon them, love and strife, were infinite. This ensured both the diversity of the universe and the possibility of change. It was like having a finite set of ingredients, but an infinite number of recipes, resulting in a boundless variety of dishes. Section 5. The enduring legacy of ancient physics. The ancient Greeks laid the foundation for Western intellectual tradition. Their ideas about the universe, though often speculative and lacking empirical evidence, were incredibly influential. They grappled with fundamental questions about the nature of reality, change, and the limits of human knowledge. Their emphasis on observation, logic, and the search for underlying principles paved the way for the scientific revolution centuries later. Their fascination with contraries and the interplay of opposing forces foreshadowed modern concepts like duality in physics and the dynamic equilibrium of ecosystems, while modern science has surpassed many of their specific theories. The spirit of inquiry and the pursuit of understanding that characterized ancient physics remain as relevant as ever. Their ideas continue to inspire us to look beyond the surface of things, to seek the hidden connections, and to marvel at the beauty and complexity of the cosmos. As we continue to explore the universe, from the smallest subatomic particles to the largest galaxies, the echoes of these ancient thinkers remind us that the quest for knowledge is a timeless human endeavor.